we are going to talk about a different type of tools, the parallel debuggers. But before we start, I would like to do my little who are you survey. So how many of you used the debugger before? And like, how many of you used TotalView or DDT before? Okay, so I think we should continue. So before we start, I will do a live demo. So in order to view the movie, you need to have a tool to view that. So I'm using VLC. So if you have time to install that, if you don't have any movie viewer that supports the WebM format, then you should download VLC and install it. Otherwise, you won't be able to see the video. So, and so it's, of course, the slides and the exercise are in Slash project, so you can copy them if you want. And there is also a website called HPC Forge that we use at CSCS to put all our nice development. So if you go to hpcforge.org and then you type CSCS code, you will arrive here, and that's, if you click, so let me know if I'm going too fast. So if you click here, you will arrive on the main page of the CSCS codes page, and then you can click on the wiki page. That will get you here, and then you get on the page for today. And I put the links to the VLC page and the videos for the debuggers. Okay, let's start.
Can you show us again?
Yeah, so it's hpcforge.org, and then you look for CSCS codes.
Okay.
And then you click on the wiki here on the right, and you get on the main page. So after you install VLC, you can download the movie by just clicking on the link. That will open a new page where you have the link. You have to download that file, the .webm file, and then you can open it with VLC and you will see everything. Okay, so I'm going to talk about bugs and debuggers. So bugs are the problem, and debuggers are the tools that are going to help you to find the solution for your problem. So it will be a quick overview. I would like to keep some time for the exercise. But if you need a more advanced view of the debuggers, we will organize a course in March next year. So you are welcome to come to learn more about debuggers. But right now, I would like you to get used to the debuggers. We are not going to see everything, but if you can start your application with a debugger, that's my goal. And then I will do the live demo, and we will finish with the exercise. So, by definition, a bug is something that prevents you from running your application, and that's of course something that you didn't plan to have because it's an error in your code. And as Neil likes to say, nobody wants to run fast but giving wrong results application. And in that case, bugs can be can harm you. So there are different types of bugs. The most common ones are parallel bugs, like for example the OpenMP data race that we will see in the exercise. So for example, the data race is when more than one thread is trying to access a variable and overwrites the value of the variable, and that's typically a problem of parallelism. You can have also memory bugs, like leak, and of course numerical bugs where your application doesn't really crash, but it gives the wrong results, and you don't really know why. And if you look back in history, a bug, it was really a bug. It was an insect that used to go into the machine room and would like to eat the cable of the machine. And of course, that was a problem for the computer. So you have different types of debuggers on the market. Most of them can debug any language like Fortran, C, C++. And of course, you have they support MPI, OpenMP, hybrid codes, also next generation languages like CUDA. The most simple debuggers are command line interface, and the most advanced ones have a nice graphical interface. But the problem with some of them is that you have to buy them, so they need a license. But if you have a simple application, you can use the debuggers that come with Linux, for example, like GDB, or the graphical interface that are on top of GDB, like Nameweaver. That's all open source. The commercial debuggers are TotalView from RogueWave and DDT from Alinea. They are very nice and expensive debuggers. They are installed at CSCS, but you probably can ask your site if they want to buy a license for them. Eclipse is a very active project that is being used on the big HPC sites in the US, and that's going probably to be the main debugger in the future. Right now it's under development, but it's full of promise. And last but not least, Cray supports a debugger based on GDB that is called LGDB. That is very nice because it's not limited by a license, which means you can, if you want, debug your application on the full system. So in the case of Rosa, that's more than 47,000 cores. And of course, the last solution, if you don't have a debugger, is to insert printf inside your code and see the value of your variables and try to find something. And the last thing is, of course, the various compilers have debug compilation flags where you can say, okay, show me what's wrong in my code before it crashes. But the advantage of a debugger is that, okay, let's say you don't have a debugger. What you do is you modify your source, insert some printf, compile your source code, run your application, look at the output of the job, then go back to the start of the loop, modify your source, recompile, rerun, look at the output, and that can be a very time-consuming process. And the advantage of the debugger is that you don't need to recompile, because at least you need to recompile at the beginning, and then you can restart your job and examine, inspect the value of some variables during runtime. So to do that, you just start the debugger, insert what we call a breakpoint that will stop the execution of your application. Then you inspect some variables. You can compare the value of the variable between the different MPI process or the different OpenMP threads. And when you're happy, you finish the execution and you can modify your source. So for the demo, I chose the very simple hello world example. So on the left, you have the C code, and on the right, you have the Fortran code. So it's a hybrid MPI OpenMP. So at the top, you have the call to MPI, then the call to OpenMP, and then I just print the number of MPI tasks and the number of OpenMP threads. And I will show you that it's possible with the debugger to see that at runtime. So if we go back to the website, I will open one file. So basically, the 4 files are the same. I'm just changing the debugger or the system. In that case, it's either Rosa or Pilatus or TotalView or DDT. So let's start with Rosa and TotalView. So since it's a graphical interface, you need to log in with Xdisplay. So you need to load your compiler. In that case, it's the Cray compiler. Okay. So first, I will show you, I will execute the code without the debugger to show you what it does. Okay, so here I'm getting the source. So that's the compilation. So the important part here is that you have to put -G if you want to be able to see the source code inside the debugger. And then, of course, the OpenMP flag. OK, so let's run 2 MPI tasks, 1 task per node, and 3 OpenMP threads. So I'm asking for 2 compute nodes. OK, 3 OpenMP threads. It's coming. So here, I'm asking for 2 MPI tasks and 3 OpenMP threads, and the one in the middle is just saying that I want to run on 2 compute nodes, which means that 1 MPI task will be on the first node and the second one on the second node. And the appearance.x, it's the same command as appearance, but we need a special appearance for the debugger, so that's why. Okay, so only 1 MPI task. And you see here, I have, for the first MPI rank, 3 threads. For the second MPI rank, 3 threads. And each MPI task is running on a different compute node. So let's try to do the same with the debugger now. So by default, on the Cray, the TotalView is loaded by default. So you need to do to copy some file if you want to run on the Cray. So the only difference with before is you have to put before IP run total view and just after it -A to show that, okay, maybe that was a little bit too fast. So that flag is used by total view to tell him that everything after -A is used by your application and not for total view. So it's to make the difference between the flags for total view and the flags for the application. So that's going to start the graphical interface. So you just press OK, start. So you have different buttons. You can start. And in that case, it gives you the choice between yes and no. So when you have a bug, your application crash, and maybe it will generate a core file. So that's a segmentation fault most of the time. So in that case, you don't want to stop the job because the job will crash, and the debugger will stop the execution just before the crash so you can see what's happening. But sometimes your application doesn't crash, it just gives a wrong result. So you need to navigate into the source code to find exactly where the problem is. And that's a little bit more complicated. So in that case, you will say, yes, I want to stop the job because I want to stop the execution in the middle of the code. So that's what we are going to do now because my code doesn't crash. So you see, you have different windows. You have the source code in the middle with the MPI and the OpenMP part. And on the top, left and right, you have the stack trace and the stack frame where you can see the values of the variables. And actually, you can always see there are different ways to compare the values of the variable between the MPI task and the OpenMP process. So the first one is just to, if you look at the top, there are two lines. So in that case, we are on MPI rank 0, MPI task 0, and thread 1. So that's probably the first OpenMP thread of the MPI task. At the bottom, you have P and T. So if you want to navigate between the different MPI processes, you can click on this button. Yeah. That's not really useful.
You can use there is a pointer.
Yeah, it's better. So here you can navigate between the MPI task or between the OpenMP threads. And then you can also right-click on your mouse and say, I want to see the value of that variable, for example. So here, the little red box is a breakpoint, which means that you ask the debugger to stop the execution at that line so that you can inspect the values of the variable. So here you can see that the value of thread CSCS. So here I'm navigating between the threads, so I'm changing the value of the thread, and you can see that if I change the value of the rank, here the value of rank will change too. Okay, so now I can compare the value of rank between the processes here, 0 and 1. I can the value of the thread number between the threads, so 0, 1, 2, because we have 3 OpenMP threads. So it's really simple. And it works also with arrays or... So that's it. So it's more or less the same on Pilatus, except that you have to use srun instead of epirun, but everything is inside the video, so it should be rather easy to follow. One last thing, if you find a bug and you don't really have a solution, it's always possible to send us a ticket. And if you send us a ticket, it's always good to send us as much information as you can, like which compiler, which version of the programming environment you're using, how you did the compilation of your code, because sometimes some flags may do something, especially if you do optimization flags. So basically, anything that can help to reproduce your issue will help us, and then we can send it to Cray or to the compiler team. Okay, so I'm done. Now we can move to the exercise, which are in /project. And if you have any question, I will be happy to answer.